Hello and welcome to the section 5.2 lecture. Today we're going to be talking about rewriting percent expressions. Okay? This is going to be very similar to sort of the last thing that we did in the first section, but we're going to give it a little bit more context and try to make it a little bit more applicable. So see where it actually happens in the real world. And the essential question today is how can you rewrite expressions to help you solve markup and markdown problems? Okay, a markup being we're trying to make more money off of it, a markdown being we're putting it on sale. Okay, so it says here that a markup is one kind of percent increase. You can use a bar model to represent the retail price of an item, that is the total price including the markup. Retail means the price that they're selling it for. So where this usually comes into play is companies buy things to sell. They buy them at a certain price, and then they have to make money on it as well, so they sell it for a higher price, so that whatever the difference is there, they have made some money on that item. So let's look at how we can use a bar model to do that. It says here to make a profit, stores mark up the prices on the items that they sell. That's just what I said. A store buys skateboards from a supplier for S dollars. Okay. What is the retail price for skateboards that a manager buys for $35 and then for $56? So two different skateboards. And they want to mark it up 42% to get a 42% profit on those items. So if we look at the original price that they bought it for, that the company buys it for, being S, and then they want a 42% profit. So this is the store price, what the store bought it for. And then this is the amount of profit that they want. And then to figure out the actual price or the retail price, you have to add those. I do apologize. For some reason, my pen is not wanting to work as fast as I do. So putting all these bars together, we see that the cost plus the markup is our S, what it cost us, and we're playing the store right now. It's our cost S plus 0.42 or 42% of S. Okay. So we see that the retail price, the amount that I'm selling it for, is 1S plus 0.42S, which is 1.42S, just adding those together. That's called combining like terms. Both of these have S's in them, so I can combine those. So if we use that expression to find the retail price, we're going to take our $35 and multiply it by 1.42. So if I look at that, 1.42 times 35, I do get $49.70. So that cheaper of the two skateboards, this is the price that I'm going to put in my store so that I know that I get a profit on it. I get a 42% profit. Okay. The other way that you can do this is you can just do this in two steps. You can say, all right, well, the $35 that it cost me to buy it, I can multiply that by 0.42, and that's going to figure out how much profit I want to make. I want to make $14.70 profit, and then I can add that to the original price, $35. And I get the same thing. Okay, you can do the same thing for the $56 one. I'm not going to do that right now. But in this what if problem, it says, what if the markup was changed to 34%? So instead of wanting 42% profit, I only want 34% profit. Well, if we were to go through all this, the original cost plus the markup, instead of the markup being 42%, it would be 0.34 for 34%. Gosh, come on, pen, you can do it. So we get 0.34s. And when we add that to 1, we would get 1.34s. So how does the expression for the retail price change? It's 1.34s. And basically what this means is I want to sell this. If we think about this number as a percentage, I want to sell this for 134% of the cost that it costs me to buy that item. Okay, and this happens all the time. I know it seems like, why would you sell it for that much more? It happens all the time. It's the way smaller companies make money off of bigger companies. Here it says Rick buys a remote control cars to resell. He applies a 10% markup. Write two expressions that represent the retail price of the cars. So using the previous example, if we use S for the amount that he buys them for, just to keep things the same, I'm going to have S plus 0.10, 10% is 0.10, or 0.1. Let's use 0.1. It's a little bit nicer. So I'm going to say S plus 0.1s. And when I combine that 1s and the 0.1s, I get 1.1 times the cost that I bought it for. So let's say that he buys that remote control car for $28. What is he going to sell it for? Well, the way we figure that out is we'll use our 1.1. It's a little bit nicer. Times 28. And as I mentioned before, we can use calculators at this point. So I'll take 1.1 times 28. And that means that Rick is selling it for $30.80. That's his selling price, or retail price. Same thing. Next one says that an exclusive clothing boutique triples the price of the items it purchases for resale. What is the boutique's markup percent? If I want to triple the price of something, I'm thinking I'm taking the sale price, the price that I bought it for, and multiplying it by 3. Okay, but where does that come from? In terms of this, it comes from my sale price, one of the sale price, plus, well, 1 plus what gives me 3? That would be 2s. And the number 2 as a percent is 200%. So I'm selling it, or not me, but this boutique is selling it for 200% of its original price. Okay? Or sorry, a 200% markup. So that's different than what it's selling it compared to its original price. Write two expressions that represent the retail price of clothes. Well, we just did. We have 3s or 1s plus 2s. Okay, the next thing is talking about calculating markdowns. An example of a percent decrease is a discount or a markdown. Okay? And I hate to break it to anybody, but even on discounts, the company is still going to, most of the time, still going to make money on that item. They're going to make a profit. So it's still going to be higher than what they bought it for. Okay. A price after a markdown is called the sale price. You can also use a bar model to represent the price of an item, including the markdown. So let's see how they use a bar model on this. So a discount store sells all of its holiday merchandise. They mark it down by 20% off of its regular selling price. So this one's a little bit different. It looks like they're selling it for cheaper than they bought it for, but they're not really. So we're going to use this idea to find the discounted price of decorations that regularly sell for $16.23. So let's figure out what our expression is going to be first. So if it's a 20% discount, we can write that as 0.2 for 20%. And since we're doing that 20% off of the sale price, or what we usually sell it for, we're going to go 0.2 times P. That's going to be the discount amount. I have no idea why this happens, because it doesn't happen in class. It's only when I'm recording that my pen slows way down. This up here is the regular selling price. And if we take a 20% discount, the amount that's left over is the amount that we're going to sell it for. And the way we figure that out is our original price minus 20% of that original price. Okay. And they're going to go through something that's going to help us out a little bit more. If we look at the sale price equals the original price minus the markdown, or the 20% of that original price, you can do this problem either way. If you do it according to really what 5.1 was talking about, you're going to find 20% of that cost and subtract it from the original price. That's using this method, which is totally okay. To me, it's a little bit more straightforward, and it feels like less math before I'm really doing math. Odds are I'm going to use a calculator anyways, so there's often times that I like using this strategy, even though there is a few more. I have to rewrite numbers, and that's the big thing that we don't like about it. I would have to rewrite the sale price each time. So the other way is to say that if I'm considering the entire original selling price and I take off 20% or 0.2, then I'm left with 80% or 0.8 of that typical selling price. So we can just take that selling price and multiply by 0.8 and we're good to go. And so they do it there. They multiply 16 and 23 by 0.8. Let's look at this conjecture problem. It says compare the single term expression, so that would be this one. This is the single term expression. For the retail price after a markup in example 1, and the single term expression for the sale price after a markdown in example 2. There's a lot going on there. Okay. In example 1, it was, if I'm looking at this, it was 1.42s, and the single expression for the sale price in example 2, this one right here, of 0.8, and they used P on this one, and that's okay. What do you notice about the coefficients of the two expressions? And this is the key here. In the markup, my coefficient, my number being multiplied by s, is bigger than 1. And in a markdown or a discount, my number multiplied by the variable is less than 1. Okay, those are the two things that we want to see. So for a markup versus markdown. The number multiplied by the variable come on, pen, you can do it, is bigger than 1. In a markdown, the number multiplied by the variable is less than 1. Okay? Coefficient, the word coefficient just means the number multiplied by a variable. Okay, let's go ahead and try this problem. Geez, these two problems. All right, the first one says that a bicycle shop marks down each of its bicycle selling prices by selling price B by 24% for a holiday sale. A little Black Friday sale going on here. So they want us to use a bar model. We can do that. I'm going to cheat and get some good looking bars here. Let's pretend that's my original cost B, sorry. So this is my B. And they sell it for 24% less. So 24 is about a quarter. Let's say that that's maybe right there. So this is 0.24 or 24% of B. And so the amount that's left over, I'm actually going to draw another bar right down here. So if I go from here to the end of this one, this is what's left over from that hole. And that's going to be, well, if I take 1B and subtract 0.24, maybe I'll do that. 1 minus 0.24 is 76% of B, or 0.76 times B. And this is my, we'll just say that's my markdown. I like showing it that way rather than your book. When they showed it, they did this. They had a little dotted line that was even with this one and said that markdown was this part. Okay, that's how your book did it. I like this version a little bit better because it shows us that if I were to put these two boxes together, they would give me the whole B, but I'm only looking at part of that. So what is the single term expression? It's this part right here. It's the 0.76 times B. Jane sells pillows. Great. For a sale, she marks them down 5%. Write two expressions that represent the sale price of pillows. Let's say that she typically sells them for price P. So let's say, let's just put a note in here that selling price is in her original selling price is P. So the two expressions, if she marks it down 5%, it would be 1p minus 5% as a number is 0.05p. So that's one expression. That's the two-term expression. The one-term expression is to take 1 and subtract 0.05, where we'd get 0.95p. If the original price of the pillow was $15, what is the sale price? Well, plug that in. 0.95 times $15. And we can just do that. 0.95 times 15. So she's selling it for $14.25. Okay, last thing we need today is we need a code word. The code word for today, I'm typing it, hoping that works out better. The code word today is going to be sale, because we're talking about sales. A little bit. Okay, so that ought to be good. If you have any questions, make sure you let me know. Send me an email. Try to get the most out of this that you can. And have a good day, and we will see you in class.